All right, welcome everyone. This is running K3s lightweight Kubernetes in production for the edge and beyond. Sorry, it's a really bad title. I'm not exactly sure what I was thinking when I proposed that one. But yeah, kind of excited to be doing this. It's a little awkward. I'm just gonna go like one straight cut, like no editing or whatever. Try to keep this authentic. So I'll probably say some stupid things. Yeah, should be fun. Welcome to my home office. You might be thinking to yourself, like, hey, that kind of looks like a closet. I'd like to refer you to the sign my daughter made. It says, "This is my office." So it's clearly not a closet. This is my home office. All right, so let's get going. Let's go to the first slide here. So just what I'm going to do, I'm going to start off and do a quick overview of K3s. I mean, this is only 25 minutes, so I can't go super deep on really anything. I did a talk on K3s KubeCon North America 2019. That was the last KubeCon, so that was roughly 3 years ago or something. So I did a talk on K3s there. That was pretty much a deep dive into what K3s is. So I'd really refer you to that talk, and you'll get a lot of the technical details of what K3s is. I'm just going to go over just a high level, just kind of understand what the goals are and everything, and talk about some pointers about the project. And then specifically with this talk is I'm going to go into these 3 use cases, and these are use cases where K3s kind of shines, and people have had good success running K3s in these different things, and just kind of point out how people are doing this. What are the what are kind of pros and cons or gotchas or whatever. So we'll talk about edge app cluster or application clusters. I'll explain that more when we get to it, and then kind of how people are fitting K3s into pipeline. Okay, so before I get started, just a little bit about me. So I am Darren Shepherd. I'm CTO and co-founder at Rancher Labs. I build the cloud on Twitter. If you ever want to get a hold of me or talk to me or anything, Twitter is really the only thing I ever really respond to. So you can DM me there. That's totally fine. Or you can follow me. I just complain about everything. So basically, I created K3s and some other Rancher projects. But K3s is kind of like my baby or something. But basically, I've been doing cloud orchestration for quite a while. So before containers, it was like virtual machines and stuff, IaaS, Cloud Stack, OpenStack, that kind of world. And then before that, different forms of bare metal and virtualization and stuff like that. Okay, so one thing I wanted to call out is as of when this session has been recorded, or does that make sense? As of today, my time, not your time. K3s was just voted through to be accepted as a CNCF sandbox project. So we are going through that process of getting K3s into CNCF as a sandbox project, and then as quickly as we can, we'll graduate through. We're really excited about this. I mean, K3s is really not that old of a project. It's only like, I don't know, a year and a half or so. It's less than 2 years old, but it's growing so fast. It's getting so many users. This is just kind of the next logical step of moving it to a foundation, trying to get more collaboration from more people in the industry. It's just kind of a win-win situation. So we're really excited about that. Just, kind of like our little project has grown up into something really quite big. And it's really used by quite a few people. I mean, lots. I mean, it's quite amazing. So I'm pretty excited about that. Okay. So let's talk about first, what is K3s? So it's lightweight Kubernetes. That's like a primary purpose. Most of the decisions and stuff that we do, like what we do in Kubernetes, like components we package, or what we like, the approaches we take is really focused on a lightweight, resource-constrained environment. So we, tend to pick lighter weight components, or maybe they're ones that aren't going to scale massively far or something, because that's not our use case. So we do focus in on this. So the binary is very small. Like K3s spec is a single binary. The memory size is, kind of like the initial memory footprint of K3s. It's probably like half the size of Kubernetes in general. You can see this really easily if you just like run K3s versus like kind kind is like more of the traditional upstream model running everything. You know, it's going to take up like twice as much memory. This is just the way we packaged it and stuff. Basically, K3s is perfect for the edge. It really lines up really well with the edge use cases. But really, in practice, it's used just about everywhere. It's really super popular, like in dev and test. It's taken up a lot in those areas. But also, people are even running at cloud data center. A lot of just random use cases that like kind of fill in gaps that the kind of traditional. And it's kind of funny to call anything Kubernetes traditional this way, but just kind of like the cloud data center model that's kind of existed and where Kubernetes shined. K3s is finding different use cases that kind of fill in gaps there. But kind of the thing that's really resonated with a lot of people is kind of like this idea of like low cognitive load. It's just easy to run K3s. You don't have to think a lot about it. And that's one of the reasons I think why it's caught on so quickly. K3s is designed for production. This is a very important thing. It's like what sets it apart from a lot of other like simple, small Kubernetes projects. This, from the very beginning, was always targeted for production. This is not a toy. It is a fun toy, but it is designed for production. Like it's secure. You know, we do patch, like we track CVEs and security issues, and you know, we're serious about all this stuff. We have like real customers and actually like very important sensitive workloads or whatever they're running on K3s. So because of that, it's fully CNCF certified. We pass the conformance test. We do that. All of our releases, like the major minor releases, they're always certified and pass the conformance test for everything. Everything's secure by default, you know, as best as we can. I think we do a pretty good job there. If there's any issues, there's, you know, security disclosures and stuff like that we'll fix that. It's important to us. But we do our best to like, you know, it's like all the TLS is properly set up by default. You know, like at-rest encryption. I think we even do that by default and things like that. So in general, we just try to follow like best practices. You know, so again, that's kind of part of like the low cognitive load. It's like it should just kind of work what we think is the best approach for lightweight Kubernetes. So because we kind of narrow in on a certain use case, we can kind of make a lot of choices for the user ahead of time of like, yeah, you kind of want it to work this way. And so by default, it does kind of the right thing for a lot of, you know, deployments in the realm of where K3s sits. The last thing is it is a Kubernetes distribution. That's like fundamentally what it is. So K3s has no goal of like becoming something else like larger, or it's like the intention is just to give you a Kubernetes distribution. It's just very geared towards like lightweight, simple, low operational overhead, things like that. So it is very opinionated. We do things a certain way, which is great. Like if you don't like the opinion, there's plenty of other distributions out there. In fact, like Rancher Labs company, you know, my company, wherever we have 2 more distributions you could pick up if you want. It is considered like, it's like complete. Like the idea is like when you turn it on, you get pretty much a fully functioning cluster. So it has like all the network policy, ingress, storage, like everything, just kind of like all the Kubernetes APIs just work out of the box. Again, kind of optimized for our use case. And we're just very, very focused on simplicity. Okay. So these are just some random points, because as we talk about different use cases, I want to call out like, you know, it's like, I'm just going to talk about a couple of use cases that where K3s has kind of shined or whatever, but there's a lot of other things, like random things that you can be doing. And so, and the reason why these are some little things that we've done with K3s of why it kind of like to a certain degree sparks people's imagination of like solutions they could solve with K3s. So one of the things is like, it's really, really, really easy to run. It's just a single binary. You just copy it onto a server. We even have a little curl script that'll set up a systemd unit for you. But like at the end of the day, it's really just a binary. It's a single file. It's like 50, 60 megabytes, something like that. And then you run K3s server, and that's a fully functioning single node cluster. And then if you want a second one, you just run K3s agent on another machine, and you use a token, kind of a shared secret between the two to set up the certificates and all that. And then that's basically it. So it's just super, super easy to run. And like, because of that, it kind of like removes that barrier of it's like, well, it would be really cool if we had Kubernetes, but it's just too much effort. And it's like, well, no, like for these use cases, you can have it. It's really simple. Okay, so not only is it really simple to install and run, it's really easy to bundle applications with it. So there's a couple little features that we added to K3s that just make it just that much easier. So there's a special manifest directory that if you put anything in that directory, it just gets loaded. So if you're more Kubernetes savvy or expert or whatever, you might know about static pod manifest folder for the kubelet. So it works very similar to that, where like the kubelet would look for pod manifests in a directory and just automatically start them. So this is like anything you put into that directory, we're going to load it into Kubernetes. So that means that if you want to package your application, like let's say like you want to build like an image, because you're going to put this on a device or something like that, you just have to put some manifests in a directory and then put the K3s binding there, and then on startup it'll just deploy the application for you. Like no much more automation and stuff. So very closely related to manifest is also images. So a lot of times people air gap or whatnot. So you can then put images like any OCI or Docker image tarball. So like there's an OCI format and a Docker format, but we'll take either format. You just put the tarball into that directory. On startup, we'll then just pick like just we'll load those basically into containerd. So those hold on, let's take a drink. So with those two things, like you can kind of just package up an application really easy for like fully air gapped and everything. There's also little hooks in that image directory of how to pre-pull things on start, so like they're not pulled dynamically. I didn't want to call it just in general, like K3s does not really try to address a lot of the, when you talk about like edge and stuff, we don't try to address the distribution of images that much. We kind of look at that as a slightly different problem. So if there's going to be any questions about like how do you optimize image delivery and stuff like that, K3s is not really focused in that area right now, but just a random thing there. So the last thing is we have a built-in type in K3s for a Helm chart. So like we have a built-in controller, like a Helm controller. It's a separate project from Rancher. It's a very simple Helm controller, very similar to like let's say the one from Weaveworks, which is actually more popular within the community than ours. But this one is very simple that we get embedded into K3s. And this one, so it's like, since we can deploy any manifest and then your manifest describes a Helm chart, it's really simple to get Helm charts into there too. So you don't have to run like Tiller if you were doing Helm 2, which hopefully nobody's doing at this point anymore. Or you can, yeah, so you don't have to be running Helm, this command line and, doing all that, setting up repo and pulling or updating and all that crap. Okay. So other thing about this is, basically, it's like when you look at Kubernetes, like really your biggest operational overhead actually is etcd. And it's not like there's anything wrong with etcd. It's just the idea of running a persistent system and a quorum-based persistent system like that. You have to worry about losing quorum and stuff like that. So K3s introduces other options for the data store because we recognize like that's the biggest operational issue or headache of running K3s is running etcd. So we support SQLite embedded, MySQL and Postgres for an external database. SQL Server and Oracle are coming soon. Like those I think there's PRs out there for those. Maybe by the time you hear this, they've been merged. But like you can just get a managed DB. And so that's like one of the biggest reasons people think like, oh, well, why is like MySQL better than etcd? And it's really not that. It's like, it's not comparing, like that's actually like apples to oranges. They're two different things. But the whole point of like why you might want to go with like MySQL or Postgres is you can very easily just buy it and not have to worry about it. So it like removes almost all the operational concerns of running a cluster, given that we also handle all the security and all that stuff. And so this in general is enabled by this component. It's actually a separate component called Kine, and you can use this actually with any Kubernetes cluster. It doesn't have to be K3s. Like if you're doing kubeadm, you could just add etcd, like you could add MySQL support to a kubeadm cluster using Kine. But it's just K3s embeds that directly in, but that is like a separate project. So even though we support all these kind of traditional or relational databases, we also still do regular etcd. It's still just Kubernetes. So you can do normal etcd, you can do your traditional external setup. Like, that's not fun. And that kind of stinks to run on the edge. Then there's another option, and this is one we before had a solution based on DQ-Lite, ran into some little issues with that. Mostly, I mean, there's nothing really wrong with DQ-Lite. It's just more of this made a lot more sense to go the etcd route. And so the last option we have here is running etcd embedded inside of K3s. So you can just run like 3 K3s servers, and they just join the etcd cluster, and K3s kind of manages it itself. So it's more like Docker Swarm, if anyone's run that. It's a very, very simple setup that we just put on to master in K3s in the middle of, let's see, July. And it should be like GA, sometime this year, probably like October timeframe. Okay, so let's get into Edge. Edge is like the most popular use case. I guess it's kind of well, actually, it's not really the most popular. I would say it's like the most popular one that like people kind of associate with K3s. But in fact, I think actually the most popular thing for K3s is probably dev and test environments. But when I talk about Edge, what is it that I mean? It's really what I mean is not like IoT devices and these really, really tiny devices. Like, that's too much right now. So we're looking at fairly powerful small devices. So minimum 1 gigabyte of memory. So this is kind of like in your Raspberry Pi realm, going up. Like some really great devices is like the oh crap, what is it? The Jetson Nano, the NVIDIA one. It's really powerful, small device, has GPU built in. Like, that's a perfect use case for K3s. So we're looking at smaller devices, but still fairly powerful. Like, we can't go super, super small. I can kind of tease. We have another project we're going to start that's like, if it would kind of be like the K1s. Like, we have an even like lighter version that's going to target more like 256 megabyte, and really, really less CPU and stuff. But I was going to tease that. Okay, so the type of use cases we're talking about is like retail, branch, factory, planes, trains, automobiles, wind turbines, set-top boxes, drive-through menus, your refrigerator, most likely your coffee maker. It's like these ARM computers or even Intel computers are in so many places. And yeah, I mean, over the last year or so since K3 has been out, and just kind of talked to tons and tons of companies that are just looking at modernizing all these environments. And so it's just, I don't know. It seems like there's almost, I don't know if this is a real thing, but it sounds like there's kind of more computers out there that are not cloud. As much as like my history and past has been focused so much on cloud, there's so much out there that's not cloud. It's really interesting. But basically, like, why are people doing this? One of the things, like the really driving factors, is that what people are deploying on the edge is getting more complicated. Like, the applications are more sophisticated. They're leveraging more like open source. They're doing data analytics using like different data platforms or TensorFlow, and so like they're starting, like the software they're starting to have to deploy is getting a lot harder. Like so they kind of have to up their skills in how they manage software at the edge if they want to put all this compute out there. And so Kubernetes just brings a nice consistency and approach that, is already proven in cloud and data center. So it's like, most people are just looking, how do I get like that efficiency and that simplicity, I guess, of deploying to cloud and data center with that Kubernetes brings? Like, how do I do that same thing on the edge? And so that's really what it is. It's just making it a lot easier to manage this complex software as it's kind of working. It's just kind of grown. I think one of the interesting is like the wind turbine use case. Like we work with one of the largest wind turbine manufacturers, and they practically run like a little data center in those things. Well, those things aren't very small. Those turbines are huge. But it's like the amount of computing power is out there is kind of crazy. Okay, so when we talk about these use cases, a lot of times, mostly what we're dealing with is like 1, 2, or 3 nodes. So they're kind of separating, like the 1 node clusters will be an embedded SQLite. The 2 node clusters will be using an external data store. We're looking at doing an active passive failover type solution. And then the 3-node one is the embedded etcd, but that one is like still experimental. A lot of people right now are getting by with really, if they want 3 nodes, they do a single master with 2 or 3 worker nodes, until we get like the full embedded etcd working like, you know, seamlessly. But just in general, like these solutions just have lots and lots and lots of clusters. And so there's a real fundamental difference between running like one cluster with tons of nodes and a lot of little clusters. It completely changes your perspective on how you deal with it. And what we found is a lot of people kind of resonates better to do a lot of small clusters, because it looks a lot more like a configuration management problem than kind of like an abstraction federation type problem. And so like the approach that we've seen is it maps really well. Well, I'll get into this. It maps really well to GitOps, and I'll talk about it in just a second. So in terms of edge, basically, don't go overboard. Don't use like tons of features of Kubernetes at first. Like, oops, let me go through these things of like, basically it's kind of like Kubernetes gives you this great abstraction layer over the underlying resources so that like it's scalable and pluggable and all this stuff. But when you start getting into edge, it's like, you know exactly what the resources you have. You have 3 servers, they're this big, they have this much CPU, I'm running these applications. It's fairly static in terms of what the workload is. I mean, you want to be dynamic and updating it, but it's kind of static in what you put there. So the way you plan these deployments is often very static. It's like you don't need, like you can just use host path for persistence. That makes it really nice because it effectively makes Kubernetes stateless. If you can make Kubernetes stateless, such that you wipe out Kubernetes and just start it again and it redeploys the manifests and it comes back up and everything's happy, then that's a really simple thing to operationalize. So you plan the deployment slightly different to like exploit the underlying hardware because you know exactly what it is. And also a lot of times you care because there's GPUs and hardware devices that you need to talk to. So you don't like run this kind of perfectly abstracted pattern or something that Kubernetes would kind of you normally do like in the cloud. So that's where you see like doing very explicit node scheduling or even just daemon sets. Daemon sets work really well a lot of times because it's just like, we'll run the same thing on all 3 nodes. I only have 3 nodes and I want the same thing on all of them. So just run a daemon set or a stateful set. It works fine too. So in terms of management, we kind of say like, just, first start with what you have. Like, don't go like crazy greenfield and build all this stuff. It's like, because when you look at like what K3s, like how do you manage it? It's really like, I got to get K3s on there, which is a binary. K3s is a config file to configure K3s itself. And then how am I going to deploy my applications, which are like manifests and images. So when you combine those, it's like, really, it's like, it could be as simple as rsync to manage these systems, like just copying files and like it just does the right thing. So you don't have to go super complicated at first. But the problem is like, as soon as the number of nodes or clusters you have scales up, you're going to want to centralize things. And so this is where GitOps starts to map very well to this, like a GitOps model of managing groups of clusters. The only problem with GitOps right now is that most GitOps solutions do not scale well for this edge use case because they have a push or pull. The push has a problem. It's just fundamentally not scalable because it's very hard to like push out to, thousands of clusters from a single point and then deal also with all the networking issues of doing a push model. Secondly, there's the pull model, but the problem with the pull model is you don't want to be doing the Git clone on the edge. Then you're just transferring all this ridiculous data over and then you have to optimize your Git clones. So anyways, we have a separate project. It's not related to K3s, Fleet, that we announced earlier this year, and it'll go like kind of GA towards the end of the year. Another open source project that's kind of addressing some of these issues, but just pointing out some of these things. Like the model of GitOps maps really well, but there are some problems with it. Other little challenges and gaps that you're going to run into is most Kubernetes tools don't scale for edge. So it's like the whole reason why you want to use Kubernetes is because you get all like Kubernetes stuff, but they don't like, let's say like Prometheus or monitoring, those type of things, they don't work really well for edge deployments. A lot of things won't deal with bad network connections. And then fundamentally you still have like a hardware and OS management problem. So these are things, these are kind of things that like we're looking to address within maybe in the K3s project or layers above it. Like it is important for us to kind of keep K3s focused and simple, but So some of these management problems, probably we have other like fleet, things like that, other projects that like at Rancher that we're working on, all open source, to address some of these issues. Okay, so I'm really bad at time management. So I went through like pretty much all of Edge, and I'm pretty much out of time. I'm going to talk about what app clusters are, and then I probably won't talk about pipeline that much. So you can download the slides or ask me questions. We're going to open this up for questions in a second. But let me just throw out app clusters because it's a really cool idea, and it's so simple to run too. And it's basically the whole idea is like you just have a cluster which is dedicated to one application, and you deploy it on the resources needed for just that one application. It could be 3 nodes, it could be 1 node, it could be 5,000 nodes. It's kind of funny because K3s, while we target very small workloads or clusters, it in fact will scale to 5,000 nodes just fine. We've tested this. It works. It works very well. But the whole idea is you create a cluster just for an application, and you don't really treat the control plane as a separate thing. You just kind of embed it within the resources that are using it for the application, and then use something like a managed database to store the state. So your deployment, you can have these very complicated applications which run on top of Kubernetes and do fancy Kubernetes things, but the underlying cluster deployment is just brain dead simple. You spin up RDS, and then you just point all the K3s nodes to RDS. So it's really simple to automate, and it creates a very simple, reliable cluster. And so I just want to throw that out there, this idea. Like, I don't have time to go in depth, but please, if you have some questions, ask them. So I'm not going to go over a pipeline. Unfortunately, just bad time management here. I told you I wasn't going to do any edits or anything, so kind of screwed that up. But anyways, so I think I will open it up for questions. I think that's what we're doing now. And that's it. All right, thanks. It was fun.